It's no easy task keeping a supercomputer running. Large data has to flow freely. Variables must be fine-tuned. Achieving these feats has led to some amazing breakthroughs, accomplishments that were recently recognized by the scientific community. Film has the Oscars. Music has the Grammys. But for achievements in science and technology, there's the R&D 100 Awards. In 2023, several teams from Lawrence Livermore National Laboratory won this distinguished prize, including 2 that solved unique computing problems.
It's getting to the point now where the compute cores cannot be fed with data fast enough to actually do computations efficiently, so they oftentimes have to sit and wait for the data to arrive. So it's becoming more and more important to limit the amount of data that has to be moved around the computer. And that's something that we're trying to address by compressing the data and essentially moving fewer bits of data. So data compression is a way of taking redundancy in data and making it smaller. The ZFP is a numerical compressor. That's something that's fairly new in the high-performance computing community. We're very familiar with text compressors as well as image compressors, video compressors, audio compressors, and so forth. So what ZFP does is that instead of looking for patterns like recurring words in a text document, it actually looks at consecutive values in the numerical stream that oftentimes are very similar. ZFP was really designed to support random access to compressed data, and that's probably one of its unique capabilities. Instead of having to essentially rewind the tape and start decompressing from the beginning to the end, the users of ZFP can go directly to the piece of the data that they're interested in. It's primarily for doing large scientific simulations involving numerical data. That tends to be things like climate science, weather modeling, doing fluid dynamics, and problems like that. So it's primarily for scientists doing large simulation runs at the lab. We also have other applications within experimental and observational science. For instance, we have the large space telescopes that generate huge amounts of data by surveying the sky. It is super exciting, I gotta say. I've been doing data compression work for about 20 years now. And way back when, it used to be that compression was really only used to reduce storage requirements. And these days, with the changing hardware trends, we're seeing that compression is actually becoming more and more important. So it's super exciting to be working with science and engineering applications and actually see them be able to do science that they otherwise would not be able to do without the availability of compression.
We have some of the fastest supercomputers here in the world. They consume a lot of power, and we want to be as efficient as possible. So a compute node level has many dials for managing power and performance and energy and thermals, and these are very important when you're doing application tuning. So we have lots of diverse processor architectures here at the lab. They come from different vendors like Intel or IBM or AMD or NVIDIA, for instance, right? And each of these different architectures expose different tuning mechanisms. That's what we mean by the word dials here. They can be used for monitoring as well as control. So they impact performance of applications running on this hardware, of course. Users were finding it very difficult in the past to tune with low-level dials. The reason being they vary from vendor to vendor. So they would have to know about each of these different vendors and architectures in great detail, and it was complicated and often poorly documented. So Variodem provides uniform application programming interface, or API, to our users so they can access these dials in a vendor neutral and an open source and an easy manner. It makes us more aware of the power and energy usage that we have. And that awareness is a good thing to have because that helps us make better decisions in terms of how to procure systems, maybe 10 years from now. It also helps us understand how to write more efficient code. So I do think that all of that impacts sustainability.
Variodem, Vendor Agnostic Computing Power Management, Lawrence Livermore National Laboratory. It supports all 3 upcoming U.S. exascale supercomputers.
Lawrence Livermore National Laboratory is proud of the ZFP and Variorum teams and their well-deserved awards. Thanks to this pioneering work, the laboratory's supercomputers will continue to push the extreme frontiers of science. For more information on these and the other R&D 100 winners, check out Science and Technology Review.